Hello, hello everybody, and I've got my fantastic assistant TT back up here. And what we're going to do today is we're going to teach you a bit about polar graphs. Now, polar coordinates are a different kind of graph paper, right? We've got our regular old graph paper we've always worked with that's built on squares, but if you look at my polar graph paper right here, you'll notice it's built on circles. And that ties really closely in with vectors, because remember, one of the ways we can describe a vector, we don't have to just use an ordered pair. We can measure a radius, in other words, a magnitude, and a direction angle. And so polar coordinates are built on that idea, that we're going to use the center of the graph as the origin right there, but instead of telling people how to get to things by going left, right, and up, down, instead we're going to give them a direction angle and a distance. So our first example right here is 3, 135. Now the 3 right there means radius, and the 135 degrees right there means angle. So that's telling us to go to 135 degrees as our direction, and then go out 3 rings to get to radius 3. And so if my fantastic assistant would now demonstrate.
Marker.
I'm sure we can find you a marker. There you go.
Cool. So 3, 135 degrees. So 135 degrees is here. We start here and go out. This is 1. This is 2. That is on the wrong line.
Oh, that's okay. You can go out on that one.
1. This is 2. This is 3. So your point is right here. 3, 135 degrees.
So there's our point, 3, 135. Let's try a couple more.
Okay. So this one says 2, negative 60 degrees. So since it's negative, instead of going straight to 60 degrees, we go the opposite, which in this case we go clockwise instead of anti-clockwise, which is counterclockwise. So this counts by 15s. So this would be 15 technically, like negative 15.
Oh, well, that's 0. So negative 15 would be right there.
0, negative 15, negative 30. And this technically would be negative 60 here.
That's negative 45.
Negative 45? Oh my gosh, this is bad. Negative 45.
Happens to all of us, folks.
Negative 60.
There we are, negative 60.
My bad. So you start here, and you go out radius 1, 2. So then your point would be here. Finally, find it.
There's our point right there. Okay, one more. All right, we're going to give her a chance to redeem herself. We know she can do it. One more. Okay, how about negative 3, 150 degrees?
Negative 3, 150 degrees. Okay, so it's negative 3, so instead of going towards the 150 degrees, you go opposite it?
Exactly.
Ah, okay, so 150 degrees is here, but instead of going 3 radiuses this way, you're going to go 3 radius this way, which is 2, 330. So 1, 2, 3. Right here. That would be your point.
Absolutely. So you notice, folks, negative radius means go in the opposite direction. So instead of 150, she's going in the opposite direction. All right. Now, if you've downloaded the handout, you'll notice that on the other side of the page, I've put a space for people to write alternate names. So let's talk about alternate names a little bit. We know, for instance, that this point A is at 135 degrees, 1, 2, 3 out from the center, right there. So that's telling me go 135 degrees anti-clockwise and then go forward 3. But I wonder if there aren't some other names we could come up with. And I'll bet we could come up with at least 2. So what do you think? How else could we get to here other than going anti-clockwise 135 and forward 3?
We can go radius down 3 to, where is that? Looks like 315.
So if I understand you correctly, you're saying go to 315 degrees, which is right here, and then do what?
Negative 3.
So 315 degrees would point me this way, but then negative radius would make me go the opposite direction. So that looks like that'll do the trick. Can you think of anything else we could do?
We could go clockwise to get here.
Ah, would you like to guess what that angle is?
Honestly, okay, so this would be negative 90.
Negative 90.
Negative 180.
Mm-hmm.
This would be negative 185. Negative 210. Negative 235.
Negative 235 degrees. And if you went around this way to get to it, would that be a positive radius or a negative? Positive radius. So there we go, folks. Two other ways to record the same point. Let's do one more of them, and then I'm going to leave C for you to try on your own. So here's B. And we know that we had to go to negative 60 degrees. This was negative 15, negative 30, negative 45. Right there, that was negative 60 degrees. And then going in that direction, we had to go 1, 2 outward. And again, I'm wondering, could we come up with some other ways to get to the same point?
Yes. Okay, so negative 60 degrees looks like it's 60. This is 45. This is 30, 15. This is 300. So you could say that it's a positive 2 and positive 300 degrees.
Let me see if I agree. So you're saying from here, I should go around positive 300 degrees and then go outward 2. Well, that does the trick. Okay, so you found one. Can you find another?
Okay, so then you can find the opposite 300, which when you go out would be this one.
I think that's 120. Yes, 120.
120. So you can go 120 degrees and then go negative 2.
So let me see if I understand correctly. You want me to go around to positive 120
Yes.
and then go in the opposite direction, 1, 2. Hey, that does the job. All right, so that's how you graph polar points. And interesting thing, polar points have more than one name. I know that's not true with the regular rectangular coordinates. Those squares always work the same. But when we work in polar coordinates, there's more than one way to describe the same point. And that's going to be explained in some interesting ways its effect on graphs. You'll see as you look at the video on graphs next.